The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, today we're going to go on and look at 8.2 part 2. But before we do, were there any questions from yesterday that you want me to look at right now? Anybody? Okay, then we will go ahead on to 8.2 part 2. Okay, so this first set of problems says find the domain of each function. So the domain would be the input values or the x values or the first coordinate values, the input, okay? In the case of this, f of x equals 1 over x minus 4. Well, when we're looking at equations of this type, the thing we need to avoid is dividing by 0. If we put a value of x into the function and it does not produce a real number, then that number we put in is not in the domain. For instance, consider f of 4. That would be equal to that which is undefined. Therefore, 4 is not in the domain. So domain, we could say x not equal to 4. What we're going to do, though, we're going to use interval notation to list the domain. So how would we say all real numbers except 4? Well, all real numbers would look like this, but we want to leave 4 out of the mix. So what it's going to look like is this. So I've got everything from negative infinity up to, but not including 4, and then everything after 4 up to including infinity. So this would be how you would list the domain in interval notation. Any questions about that example? All right, let's take a look at another example. H of x equals 3x plus 6. Well, is there any value of x that would make us dissolve? About divide by 0? There's no denominator with a variable where we could put a 0, so there's no restrictions here. So the domain would be all real numbers, which in interval notation would go from negative infinity to positive infinity. All right, questions there? Oh, here's another one. G of x equals the absolute value of x minus 7. Well, so after we put an x in there, we subtract 7, we take the result and get the absolute value. Again, is there anything we could put in for x which would make this be dividing by 0? No. So the domain would be, again, all real numbers. How about this one? We want to make sure we're not dividing by 0. So let's take the denominator and set it equal to 0, which we don't want. We don't want it to be 0, but let's solve it for that. We find that when x is negative 1/2, the denominator is 0. In other words, s of negative 1/2 would be 9 over 2 times negative 1/2 plus 1, which would be 9 over negative 1 plus 1, which is 9 over 0. Which is undefined. So the domain would be x not equal to negative 1/2. How would I write that in interval notation? Like that. All
So
right.
can you write either one of those, or do you have to write both of those?
When you say either one of these, you mean either one of those or this?
Yeah.
Either one of those?
Yeah.
You'd have to write the whole thing, because if you just write
Oh.
that, that's saying everything less than -1/2, but it also includes everything greater than -1/2. It just leaves out that one value,
Oh, okay.
okay? And this is what? A union symbol. So you're taking all of this along with all of that. Again, if it asks for interval notation, that's what you would use. Okay, let's see here. Next, it says graph each function. So this first one says f of x equals 2x minus 1. Well, even though we're using function notation, this function is in slope-intercept form. That is, y equals mx plus b. Remember slope-intercept form? So the slope is 2 and the y-intercept is -1. So on our graph, we have a y-intercept of -1. From there, our slope goes up 2 and over 1, up 2 and over 1, etc. So I've got these points. And here is the graph of f of x equals 2x minus 1. Any question about that? Okay, let's take a look at this one. F of x equals 2/3 x minus 2. This is also a function in slope-intercept form. The slope is 2/3 and the y-intercept is -2. So our y-intercept is at -2. The slope is 2/3. So going left to right, we go up 2 and over 3, up 2 and over 3. So that gives us these points. Graphing in WebAssign, you only need to use 2 points, but I'm using a ruler here. And so the more points I plot, the easier it is to line them up. Any questions about that one? Okay. Let's take a look at this one. F of x equals -x. Well, isn't that like y equals -1/2 x plus 0? So your slope is -1 and your y-intercept is 0. So this thing goes through the origin. From there, the slope is -1. So we go down 1, over 1, down 1, over 1, etc. Oops, didn't quite get it on the line there. I guess I can erase that and do it over. Let's try that, see if I can get a better job there. Okay. There we go. All right, there's the graph of f of x equals -x. Again, any questions on that one? Okay, how about this one? F of x equals 2. Well, that's like y equals 2. Y equals 2. Y equals a constant. That's a horizontal line. This is like y equals 0x plus 2. So the slope is 0 and the y-intercept is 2. Slope of 0. So basically you have a horizontal line going through y equals 2. All right, any questions about that? What I want to do now is I want to review some things that you should have had if you took Math 85 or maybe a beginning algebra class in high school. In either case, it may have been a while since you looked at these. So, hang on here. Let's go here. I want to review some facts. Do you remember what an x-intercept is? So let's say you've got a graph and the graph cuts through right there. That's the x-intercept. And that's the y-intercept, okay? So every x-intercept is going to have a y value of 0. Every y-intercept is going to have an x value of 0. So we say the following. To find an x-intercept, set y equal to 0, or complete the following ordered pair. Okay. Item number 2. To find a y-intercept, set x equal to 0, or complete that ordered pair. Any questions about that? Okay. A minute ago, we looked at a function that was f of x equals 2, and I said that was like y equals 2, a horizontal line. Okay. So y equals a constant is a horizontal line. X equals a constant is a vertical line. The slope formula, remember the slope formula? M, which stands for slope, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where 1s and 2s are subscripts. You got a couple of ordered pairs, you plug them in. All right. 6, the slope of a vertical line is undefined. Okay, so the slope of a vertical line is the form x equals a constant. The slope of a vertical line is undefined. The slope of a horizontal line is 0 because there's no rise as you run. We also have parallel lines have the same slope. So if lines are parallel, they have the same slope. Likewise, if lines have the same slope, they're parallel. Perpendicular lines have negative reciprocal slopes. So if you've got two lines that are perpendicular that meet at a right angle, if the slope of one is like 2/3, the slope of the other would be negative 3/2. And finally, y equals mx plus b, slope intercept form of an equation of a line. All of these were in chapter 3, which I believe you have in your book or the ebook. So if you need to review these extensively, you could go back there and look. Otherwise, anyway, we're going to move on here, and we're going to use this information in some of the following problems. Okay, so here we go. It says, write an equation for a linear function whose graph has the given characteristics. Well, typically, we write a function in that form, or actually using function notation, f of x equals mx plus b. Okay, so let's say we know the slope of a line is 5 and the y-intercept is 0, -3. That's like saying m is 5 and b, recall b stands for the y-intercept, is -3. So we'd have y equals mx plus b, but writing it as a function, f of x equals 5x minus 3. So there is the function that has a slope of 5 and a y-intercept at 0, -3. Any questions about what I just did there? Okay, let's take a look at another example. Here, the slope is 1/5, and it's passing through 10, 1. Just a point of interest, coincidentally, or maybe not, this morning in the Math 85 class, I covered section 3.6, and I basically reviewed those top 10, that list that we just went over here, right there, okay? And did some examples. So when you get all done here, if you want more information later this afternoon, that'll be posted under Math 85 Winter 2022, section 3.6, if you want to take a look. Anyway, all right. So the slope is 1/5 and it passes through the point 10, 1. So y equals mx plus b. 1/5 goes in for the slope. I need the y-intercept. This is not the y-intercept. If it was, the x value would be 0. However, it is a point on the graph. So we could take 10 and put it in for x, and 1 and put it in for y. And this would allow us to ultimately solve for b. So the slope is 1/5. The y-intercept is -1. Y equals 1/5 x minus 1 as a function. F of x equals 1/5 x minus 1. Any questions about that example? All righty. Here we are given 2 points. We want the equation of the line that passes through 1, 7 and -2, 1. Well, we need the slope and the y-intercept, and we have neither one. However, if we call this point 1 and this point 2, we could use the slope formula to find the slope of the line passing through those 2 points. Y sub 2 is 1, y sub 1 is 7, x sub 2 is -2, x sub 1 is 1. 1 minus 7 is -6, -2 minus 1 is -3, -6 divided by -3 is 2. So the slope is 2. Using y equals mx plus b, we'll take the 2 and put it right there. Now I've got 2 choices for a point I can plug in for x and y to find a b. It doesn't matter which of those 2 points I choose, but make sure you use the x and the y value from a single point. Don't use the x from point 1 and the y from point 2. That will not work. So I'm going to go ahead and use point 1. So 1 goes there, 7 goes there. 7 equals 2 plus b. Subtract 2 from both sides. B equals 5. So the slope is 2. The y-intercept is 5. Y equals 2x plus 5, or f of x equals 2x plus 5. Let's check our work. What's f of 1? F of 1 is 2 times 1 plus 5, which is 7. What's f of -2? F of -2 is 2 times -2 plus 5, which is 1. Check, check, check. Okay, now, what about this situation? It says, find the equation for a linear function that passes through 3, 0, and it's parallel to the graph of g of x equals -2/3 x minus 4. So let's go back up here. It says parallel lines have the same slope. So the slope of g of x is -2/3. So the slope of the new line is going to also be -2/3. So now we know the slope of the new line, and we know a point that it passes through. So using y equals mx plus b, -2/3 goes in the place of m. 3, 0. That is an intercept, but it's not the y-intercept. It's the x-intercept, which is nice, but that's not b. So I'm going to take that point, put 3 in for x and 0 in for y. 0 equals what? -2 plus b. Add 2 to both sides. B equals 2. So the slope is -2/3. The y-intercept is 2. Y equals -2/3 x plus 2. F of x equals -2/3 x plus 2. So are these two lines parallel? Yeah, they have the same slope. If I find a f of 3, what do I get? -2/3 times 3 plus 2. -2 plus 2 is 0. Check. Any questions there? Okay. Here we have a line that passes through 54, 0, and it's perpendicular to the graph of g of x equals 9x plus 5. So let's go back up here. Perpendicular lines have negative reciprocal slopes. Negative reciprocal slopes. So if the slope of g of x is 9, the slope of the one that's perpendicular, and I'm going to use this little thing perpendicular, would be -1/9. So the negative reciprocal of 9. So now I've got the new slope and the point. So y equals mx plus b. Y equals -1/9 x plus b. X is 54, y is 0. 0 equals -1/9 times 54 plus b. 9 goes into 54 6 times, so -6 plus b. Add 6 to both sides, 6 equals b. So I've got my new slope and my y-intercept. Y equals -1/9 x plus 6. F of x equals -1/9 x plus 6. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. So you take the slope of the original, you change the sign, and you do the reciprocal to get the slope of the perpendicular line. Okay. This says that the line is horizontal and it passes through -8, 12. Well, let's go back to this. Let's see. Y equals a constant is a horizontal line. Since it's a horizontal line, it's got to be in the form of y equals a constant or a number. But the only y value we have is 12. So y equals 12, or as a function, f of x equals 12. Any questions about that one? That's one of those problems that takes 30 seconds if you know your stuff and 5 years if you don't. Okay, hopefully you'll know your stuff. Okay. Now, let's take a look at an application problem. It says the demand for full-time registered nurses in the United States can be modeled by a linear function. In 2005, approximately, and don't worry about all these numbers, I'm going to be writing them down here in a minute. In 2005, approximately 2,175,500 nurses were needed. By the year 2015, that number is expected to increase to about 2,586,500. Let T be the number of years after 2000 and N be the number of full-time registered nurses in the US. write a linear function n of t to model the demand for nurses. Okay, so thinking in terms of y equals mx plus b, but it says write a linear function n of t. So n of t equals mt plus b. Okay, so t is time, and it says let t be the number of years after 2000. So number of years after 2000. Okay, and N is the number of full-time registered nurses needed. Number of full-time nurses needed. Okay. So what we're going to do is we're going to extract two ordered pairs from the reading. And with that, we can find the slope, we can find the y-intercept, we can find the equation of the function, and go on from there. So it says the demand for full-time nurses, registered nurses in the United States can be modeled by a linear function. In 2005, well, if t is the number of years after the year 2000, 2005 would be 5. So there's the t value. The number of nurses is approximately 2 million. I'm going to need more room than this. 2,175,500. So there's our ordered pair. Notice it's in the form t comma n of t. The input is t, the time. The output is the number of nurses. Okay. Yeah. All right. It says by the year 2015, which would be 15 years after the year 2000, the number of nurses is expected to increase to about 2,586,500. Okay, so T is the number of years after the year 2000. N is the number of full-time registered nurses that will be needed. So in the year 2005, T is 5, N is the given number. In the year 2015, T is 15, and the number of nurses is again the given number. Any questions about where I got my information? All right, so let's find the slope. We'll call this 0.1 and this 0.2. Okay, so y2 minus y1 over x2 minus x1 is going to be that over that. Y2 is 2,586,500. Y1 is 2,175,500. Back, let's move that parentheses over there. And then on the bottom, x sub 2 is 15, x sub 1 is 5. Calculator time. Okay. 2,586,000 minus 2,175,000. Oh, you know what? I did that wrong. I left out the 500. Let's start over. 2,586,500 minus 2,175,500. I get 411,000. 15 minus 5 is 10. Divide by 10, we get the slope is 41100. You're just crossing out. Okay. Just crossing out one of those zeros. All right. So now I know the slope or the rate of change. So now using y equals mx plus b, 41,000 goes in the place of m, 41,100 that is. I'm going to take either one of these ordered pairs. I'll use this one. 5 goes in for x, and the 2,175,500 goes in for y. 2,175,500 equals 41,100 times 5 plus b. 2,175,500 equals, if we take 41,100 times 5, we get 205,500 plus B, subtract 205,500. So then we take 2,175,500 minus 205,500. And I get 1970000, and that equals B. So Y equals 41,100 plus 1,970,000 X plus B, except that it would actually be N of T equals 40. Well, there should have been a, hang on here. I see what I did. Got going too fast here again. Let's go back. Let's go back. It should be Y equals 41,100 X plus 1,970,000. Okay, Y equals MX plus B. It's getting ahead of myself, but it actually should be N of T equals 41,100 T plus 1,970,000. Now, we've done the first part where it said, write a linear function N of T to model the demand for the nurses. Let's talk about what this means. That's the slope or the rate of change. That means that for every year that goes by, the number of registered, full-time registered nurses needed increases by 41,100. What is this? Well, that's the starting point. That's the number of nurses in the year 0, which is actually the year 2000. So in the year 2000, 1,970,000 nurses, they were increasing at a rate of 41,100 per year. Okay. Part B says, use your answer to part A to predict the number of full-time nurses that will be needed in 2025 if the trend continues. 2025, T would equal what? Anybody? What would T?
2025?
Just 25.
Just 25. So we want to find N of 25. N of 25 is going to be 41,100 times 25 plus 1,970,000. Okay, so again, going back here, T is the number of years after the year 2000. So the year 2025, you would be finding N of 25. Okay, and that's how you'd say it, N of 25. So let's see what we get. 41,100 times 25 plus 1,970,000. And I'm getting 2,997,500 nurses. So that's how many registered nurses, full-time registered nurses. I'm curious, this problem is old. We've already passed 2000. Oh, wait, no, we haven't. We haven't passed 2025. We've passed 2015, but I'm curious with everything that's been going on and demand for healthcare going up and people getting sick and not, anyway, be curious to know what it is right now, but I don't have that information. Anyway, enough rambling. Any questions about that example? So what did we do? Going through the problem, we extracted two ordered pairs. Keep this kind of information in mind. It's sort of a time shift. So the problem doesn't start at T equals 0 in 0 AD. It's T is 0 the number of years after the year 2000. So that makes a difference. Okay. That's all I have for you today. So I will be back this afternoon at 1:15 with an office hour. Should you have need of me, I'm going to go ahead and stop the recording.